So this is exciting. We're now going to learn a new function, logarithms. So here's the type of question you would get. 2 to the power x equals 3. Now, if this was yesterday's lesson, we would solve it by trying to get the same base. So what's the problem today? We can't. They're already prime numbers. We can't switch them to something else that will get anything. So we need to have a new function to actually solve it. So each operation has an inverse operation, a way to undo it. For example, a squaring and square root are inverse operations. The inverse of an exponential function or equation is a logarithmic. I don't have an H there, sorry. A logarithmic. I don't know why there's 2 spaces. I think it just got continued to the next side there. Is a logarithmic equation. In the upcoming lessons, okay, so in upcoming lessons, we will be looking at solving exponential equations using logs. First, we need to know what a log is, essentially. So, do you remember how to write an inverse? That's the inverse notation that you're talking about. So what was the process of finding the inverse? Switching the x and y, very good. So x equals 3 to the power y. And then what was the next step in finding the inverse? Solve for the new y, right? So here's our dilemma. We can't solve for the new y because we don't know how to get this exponent as a whole number so that it's in y equals form, right? To make the inverse function. So, same with this one. So if I switch the x and the y around, x equals 10 to the power y. I don't know how to get what y equals. So I'm going to show you. So, logarithmic notation. So here's how it works. These are equivalent forms. So if I write an exponent like this, I can rewrite it in logarithmic. So what happens here? The y that's the exponent becomes what the logarithm is equal to. The base of the exponent becomes the base of the logarithm. And what the exponent is equal to, or the power, is what the argument of the log is. So we'll have the argument, it's a big word. B is the base. So it's the base in both. Y is the exponent in the exponential form. And x is the argument, and that is the power of what the whole exponential form is equal to. So for instance, 3 squared, if I change this into logarithmic form, do you see the base of the 3 becomes the base of the exponent, of the logarithm, sorry. The exponent becomes what the logarithm equals. So I kind of use the same analogy when you first started using radians. A lot of you turned every question into degrees to solve. Do you know what I'm saying? It'll be the same thing until you get your brain wrapped around what a logarithm is. It'll just, like a light bulb turn on, you'll get it. So until you get that, you'll probably be changing it always to exponential form to actually solve. So, and by the way you're supposed to actually pronounce this is not log 39. It's supposed to be the log of 9 base 3. Logarithm of 9 base 3 equals 2. Yeah. Okay, so let's practice changing from log to exponential, exponential to log. So for instance, I'll start you off on the first one here. So remember that I always start with, the base. So the base is this little 3 here. So that becomes the base of the exponent, right? And remember that the logarithm always equals the exponent. So see this big 3 here? That's actually the exponent of the exponential form. And so that, of course, equals 27. So do you see it works, right? 3 cubed is 27. So I'll give you a moment to try to switch these back and forth. Try this. So this would be 10 to the power 2 equals 100. This would be 5 to the power 3 equals 125. Yeah. So, yeah, exactly. Because they're numbers, it's pretty easy to do. So then when it's actual variables, it's a little bit harder, but maybe not. By the time you got to D, you already knew what you were doing, right? So P to the power N equals Q. Yeah? Okay, so the way I always rewrite exponential into logarithm, I always start with the exponent. So then it always kind of flows into each other. So do you see the exponent is x, so I go x equals. I always start with that, okay? And then I know the base is 4, so then I know the log base has to be 4, and then whatever's left kind of just flows into where it's supposed to go. Do you see what I'm saying? So, again, the exponent, so that's y equals the log. The base is 3, and the 9 goes where the leftover spot here. So if you see log of 9 base 3, you know that that's equal to whatever that exponent is, right? Which would be 2. Okay, so let's keep going. So 4 equals the log of 16 base 2. And again, m equals the log of n base a. Did everybody get that right? Okay. Okay. Oh, before I go on to the next page, can anybody tell me now what y is equal to when we were doing our inverses back there? What would y equal here? Log. The base is 3, so log of x base 3. And what about this one? Log. The base is 10 of x, yes? Okay, so does everybody see? The exponential, the inverse is a logarithm because they undo each other, right? Okay, so we're going to write an exponential and then solve. At some point, you are not going to actually do this anymore. You'll just know what the answer, in fact, is. So if you know what you're looking for, it's pretty easy. For instance, when I'm finding the value of a log, I'm looking for the exponent, right? So this exponent to which the base 2 is raised to get the argument 16. But again, if you don't have your brain understanding that yet, it's way easier to change it to exponential. So 2 to the power y equals 16, and then solve what you did for last night's homework. Solve what the exponent should be. So 2 to the power y equals 2 to the power 4, so y equals 4. Yes? You don't have to do it. These are 1 mark questions, so all I'm looking for eventually is just 4. Done. Right? Okay, next one. That is y equals right there. Oh, yeah, I would go like this. Right? Equals 4. Okay, so 9 to the power y equals 3. Does anybody know what y is? It is 1/2. And if you didn't know, it would be 3 squared to the power 1/2 equals 3 to the power 1. 9 is 3 squared, right? So 2y equals 1, so y equals 1/2. But once you get good at this, again, 9 to the power what gives you 3? Well, you have to square root it to get 3, and that exponent is 1/2, right? Okay, so next one. 9 to the power 1/2 equals x. So yeah, x equals 3. Very good. Okay, next one. 1 equals log x. Notice there's no base this time, so this is something that you need to know. No base means the base is not base 1. It is 10. It's the base 10 system, right? Yeah. So from now on, if you do not see a base in the log, you have to know that that base is 10. So this is the reason why when you change things in pH in your chemistry class, you got 10 to the power something when you were doing that. Do you recall what I'm talking about? Okay, we will be doing things on pH coming up, but You probably didn't realize why you were doing what you were doing, but now it'll make sense, right? So how do I find what x is? The base is 10, so 10 to the power 1 equals x. So of course x equals just 10, right? Yes? How about this one? This one doesn't have a variable. So if you want, you can introduce a variable by saying this equals, say, x. But at some point, you're going to you don't need to introduce any variables, and you just can look at it and give me the value, right? So again, I'll change this into exponential. So 2 to the power x equals -4. Yes? You can put the brackets, but it doesn't really mean anything. The reason they have brackets here is because so it doesn't look like log subtract 4. It's the logarithm of -4 base 2. Okay, so we need to get the same base to, or we can just look at it and tell at this point. See, that's the thing. Can you ever get this into a negative number? No. So here's the thing. Because I said it equaled x, I was actually solving. In that case, I would say no solution. But the original question said find the value of that, right? So what would the value then be? Undefined. So, well, I think at some point you got to understand the difference between undefined and no solution. No solution is when you actually are solving for an unknown value. This is not an unknown value. This is a value we're trying to evaluate. And because we're trying to evaluate something and there is no value for it, it's undefined. When we get into calculus, it's even more definitive than that. But because I did it this way, I would be saying no solution. But really, the question didn't actually say that. The question said, find the value of that. So then I would say undefined, right? Well, at some point, you're going to get to the point that 2 to the power what is -4. And the what is what you would have it equal to.
So on the log graph, we can have asymptotes.
So we already kind of talked about the common log. The common log is a log function with a base of 10. When a log is written without a base, it's assumed to be 10. So from this time on, anything that has no base, that's a 10. So on your calculator, grab your calculator. You have an LOG button. That stands for logarithm. Your calculator log button is for base 10 logs. So can you find the log of 2? So grab your calculator and punch it in. Log 2. Enter. So you get 0.30103, yes? Something like that? Okay, so what does that mean? It means 10 to the power 0.30103 blah, blah, blah is equal to 2. So just for fun, go 10 with the little caret thing to the power. Your previous answer, enter. What do you get? You get 2, right? Okay, find log of 5 now. And somebody needs to tell me what it is. Six, 9, 8, 9. Thank you. Okay. Did everybody get that in their calculator? All right. So just to make... Okay, so to make your life easier, I highly suggest you memorizing this. This will make a lot of the questions really fast on the test, because I know some of you are having trouble finishing. So you need to learn some of these things. So does anybody think they know what log of a base a would be equal to? It is. Do you know why it's equal to 1? Well, let's change it into exponential. The base is a. And a to the power what? That's what we're trying to find. The exponent is equal to a. Well, what's the exponent of a? 1. So that means your what is your 1. Do you see that? Okay, let's look at this one. Log of 1 base a. Very good. It is 0. Again, a to the power what is 1. Well, the only way you could get 1 is if it's to the power 0, right? So your what is 0. Make sense? Okay, next one. It is x. Good job. So why is it x? again, I'll change it into exponential. So a to the power what is equal to this whole thing here, a to the power x. You see your what is x, right? Okay, how about this one? This one's a little harder maybe. Anybody want to take a guess?
Just like A and all three.
Nope. Nope. Not 0, no. It's equal to x. So it's whatever this argument is, and I'll tell you why. So again, this, although it has a logarithm in it, it's actually an exponential. It's an exponent, right? So a to the power this exponent is equal to what? So let's change it into what? So I'm going to rewrite this and call it let a to the power log of x base a equal to y. Okay, I'm just going to let it equal y so I can show you why it's x. So I'm going to change this into logarithmic form. So remember how we do that? The exponent is what the logarithm equals. And in this case, our exponent is this whole thing here, right? So the exponent is equal to the log, the base of the exponent, y. Do you see? So do you see this part right here is all the same, so that means this x must equal what this is equal to, so that's why it's x. Once we get, I know, once we get some more logarithm theorems, it'll be actually easier to prove, but this is the best way I can show you how it's equal to. So basically, if I have 3 to the power log of a base 3, I don't know, say a, what's it equal to? As long as these bases match, it's equal to that a, right? No, it's just whatever the argument is in that exponent, as long as these bases match, they're equal to, for the same reason I just showed you there. Okay, so this next example was actually on the provincial exam one year, and this is on the non-calculator part. So does anybody think they could estimate the value of log of 35 base 5? 7. Is 7 a good guess? Oh, what just happened to my stuff here?
It'll be great.
Okay, so the justify of the answer is how you're going to get your mark. So a lot of people say 2 point something, so that's a good guess. So 2 point what?
4.
Okay, so how am I getting this 2 point something? Well, yeah, 5 squared is 25, and 5 cubed is 125, and 35 is pretty darn close to 25. So it's probably about 2.1, 2.2 would be an acceptable. Therefore, log of 35 base 5 is approximately about 2.1, 2.2. Because it's because it is much closer to 25 than 125. So do me a favor. Did you know you can do this on your calculator if you have the fancy gray ones, or that one, the silver? Yeah, you can actually change the base of your calculator. It's one in the math functions, I think, or maybe some of you actually have the updated version where you can actually change the base. So try to find. So we're going to sketch y equals 2 to the power x. Hopefully everybody has no problem doing that at this point. So it goes through 0, 1. At -1, it's a half. At 1, it is 2. And we have this like that. Yes? If you want, we can go 2, 4 just for fun. Just we have another point there. Because how do we graph an inverse function? Do you remember? Let's switch the x and the y's around. So let's do that. I'm going to do it in a different color ink. So inverse means I'm switching. The 0, 1 now becomes 1, 0. Remember, we're switching 0, 1 becomes 1, 0. 1, 2 becomes 2, 1. I forgot to draw my asymptote. That's okay, I'll go back. 2, 4 becomes 4, 2. And I forgot this negative 1/2 becomes a half negative 1. So there. So it looks like this. You see where my asymptote is now? Yes? It was there, and now it becomes there. So a logarithmic function is the inverse of an exponential function. Therefore, it is reflected over the line y equals x. So let's sketch y equals 10 to the power x and its inverse. I did, right there and right there.
Well, it goes through it then.
Okay, next up, y equals 10 to the power x. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'll put 10 there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 there. Again, it goes through 0, 1, 1, 10, way up there. And for negative 1, it would be at a tenth. So it increases very fast. So there is my y equals 10 to the power x. Again, to do the inverse, we can reflect it over the y equals x, or we can switch the x and the y around. So 0, 1 becomes 1, 0. 1, 10 becomes 10, 1. A tenth, sorry, 1, 1/10 becomes a tenth, negative 1. Sorry, I said that wrong. Negative 1, a tenth, becomes 1/10, negative 1. So you can see it goes like this. Okay, so what are some of the common characteristics of log functions? All the graphs pass through the point. No, that was exponential with 0, 1. So now logarithms all pass through the point. 1, 0. This is the x-intercept. And like the exponential had no x-intercept, the logarithm has no y-intercept. The domain of the exponential was negative infinity to infinity, and the range was 0 to infinity. Guess what happens when you find the inverse? The domain and the range switch. So what's my domain this time? 0 to infinity. And my range is negative infinity to positive infinity. And before, I used to have a horizontal asymptote at y equals 0. So now we have a vertical asymptote at x equals 0. Very good.